Hey guys, thanks for checking out all of our videos at Three Phase Innovations. This little demonstration we're going to do right here, these are two Wye-Delta banks. This one's built at 30 degrees displacement, this one's built at 210. We're going to show what could happen or what not happen, or what you're going to get with your meter when you try to phase these banks in. Both of them are straight 240s. They do not have a ground reference on either one of them. And what we got here to prove this, we went over some videos before about the low impedance settings and ones with high. Well, this is a low impedance meter. So remember what we talked about in some of the videos before. If you don't, check it out. The deltas, the straight deltas, there is a voltage there, but it's kind of considered a phantom or stray voltage as far as when you go to ground. So you're not going to get anything. So we're going to show that straight 240s. Phase to ground, we get nothing. And this meter should vibrate, and it also makes an audible ringing noise whenever it has voltage there. Nothing there. All right. What these banks need to do is they need to have a reference to each other. So what we're going to do is we can actually tie one of these phases together, and then we're going to get a reference to each other. We're now going to de-energize the bank. What I'm going to do is a little bit different here. The banks are built 180 degrees out, and we know that. And vectorially, using the wheel back here, which we'll have to get into in later classes or discussions we have, the way this works, we're going to show that the bank is 180 degrees out. But what we're going to do is we're going to go ahead and tie A and C together. Make sure that's correct. A off of this bank, and C off of this bank, and A off of this bank to C to this bank. All right, we're going to go ahead and energize this. All right, we know that we're 180 out. Now we got continuity. Now we're going to go over this other A and C. We've got continuity. B phase. Right at 480 volts. We're going to de-energize this bank one more time. We're going to go C phase to the A phase. That's got these two banks tied together in a loop. We're going to go ahead and re-energize. Continuity, continuity. $240, $240, we're getting 480 across. The reason this is important, guys, is you make your first step. Let's just say we put our jumper across, but this is all black wire. We don't know what's happened with the other pole down the road, what the guy's done on his bank, what you've done on their bank. But somebody comes in the middle, they go ahead and put a jumper on. But first they check it with their meter. Not for sure, but they assume it works because it's a low impedance meter. For this one, something right here, even if you have a high impedance meter, it's going to show something on the meter, but it's really not the best way to check it. But by putting one jumper on, you need to start testing immediately. Because what just happened right here is if the phases were swapped right here, and we went down the line and put a jumper, and then we put a jumper, and we were testing it with the meter on the second one, we thought, man, we've got it. We're going to get down here to the third phase. It's got to be it. What does it matter? Just like we got here, we got an empty phase. We need to jumper it out. I don't need my meter. You're going to grab that jumper, put it on, try to bolt it together. You're going to get 480 volts in your face blowing up. That's the dangers of this. So one good thing about this model, what it can show. But anyway, there is another way to reference this to each other. We're going to de-energize it real quick. A little bit more time consuming, but what you would have to do, if you're worried about that situation, we can go up here and take one of your grounding straps, tie it to X2, go over here to this transformer, grounding strap, tie it to X2. It's going to run through the can is grounded. through the secondary side, same thing over here, runs through X2, the can is grounded. Now we have a reference point on the neutral between the two banks. Phases aren't tied, but they have a common point through ground. Like I said, this is a temporary fix, especially if you just want a straight 240 bank. Now we're going to energize it. Sorry, we're getting 240 on that, 240 on that. This is A and C, but I've got a ground right in between A and C. On A, 480. The point about this is they're not going to tie. So by throwing a quick ground reference on them, that's another way you can do it. But anyway, this actually goes on to a little bit more extensive training as far as the lessons and showing on the vector wheel how to do this. But this is just a real quick lesson on how to tie some of these vectors, how to tie these two delta banks together, Wye-Deltas or even delta-deltas. But anyway, check out some more of our videos at Three Phase Innovations and we'll be getting some more out to you. Thanks.